Okay, so this is section 9.1, linear inequalities in two variables. Before we start, let's do a quick review of solving inequalities and how they graph on a number line. So really solving inequalities is the same as doing regular algebra, except now instead of having an equal sign, you have an inequality sign. There is one major difference that we'll hopefully see in a second. But if we look at example A, I guess the first thing we can do is just add 2 to both sides. And so we get 3x is less than or equal to 12. And then to solve for x, like before, we would divide both sides by 3, so x is less than or equal to 4. And of course, if we wanted to draw a number line, here's 0, 1, 2, 3, and 4. We'll draw a big dot and we'll make it solid because of the equality. And since it's less than, we'll shade in everything to the left. Okay. Now we'll do the same thing for part B. I like to isolate x on the left side, so I think the first thing I'll do is subtract 7x to both sides. So I'll get 24 now minus 4x, which is less than negative 6. I want to isolate x, so I'll add 24 to both sides. 24, 6, that's 18. So now what I have is negative 4x is less than 18. We'll divide both sides by 4, and you'll get x is negative 18 over 4. Or I guess some people will simplify that to 9 over 2. Now here's where you need to be careful. That sign actually has to change. Why? Well, let's just take a look. If I had the number 4 and I had 8, is 4 less than 8? I think so. Well, what happens when I divide both sides by a negative number? Let's say I divide both sides by negative 2. What you'll get is now negative 2 and negative 4. Is it still less than? No, it's actually the opposite. You have to switch the signs. So whenever you divide by a negative when you're dealing with inequalities, please remember to switch the signs. And then once again, the number line here, I will go to negative 4.5, right about here. Open dot this time because there's no equal sign, and let's shade to the right. Now solving linear inequalities in two variables requires us to show it by graphing, okay? Not by using a number line, because of course there are two variables, okay? So what do? We use a coordinate grid. So to do so, we treat the inequality like an equality, just like how we did it before. We just pretended like these algebra questions were just equality questions. And then afterwards, instead of shading one side of the number line, we're going to shade one side of the actual coordinate plane. So let's take a look at this example. Okay, so let's see if we can solve the following linear inequality. So the reason why it's inequality, once again, here we've got a sign that says y is greater or equal to 3x plus 1. Well, like I said, my first step is just to graph out the line y equals 3x plus 1. And from grade 10, I hope you remember that this is a line with slope equal to 3 and the y-intercept equal to 1. There's 1, slope 3, go 1 to the right, 3 up, connect the dots, 1 to the right, 3 up, and there we go. Now that's my line. Okay, it's like that dot that we created before for our previous question, like this dot. And just like before, we had to shade in one side of the number line, so here we had to shade in one side of the graph. Now how do we tell which side of the graph to shade in? There's many ways to do it, but I think the quickest one is to choose a test point. So step 2 is to now decide which region to shade in. And the shading represents the correct answer. I'm going to use what I call a test point. So please pick a point on this coordinate grid, any point except for points that are actually on this line. What's the easiest point to choose? How about 0, 0? So that's right there. Now what I'm going to do is I'm going to plug in 0, 0 into the equation. Okay, so y is 0, less than or equal to 3 times 0 plus 1. And I want to ask myself, is the result a true statement? Is 0 greater or equal to 1? In this case, the statement is false. So when it's false, you want to shade in the side not containing the test point. And so therefore in this question, I will shade in the side to the left. And that's your answer. Okay. Now the graph on the right is exactly the same except for one thing. It's greater than, not greater than or equal to. So just like before when I had an equal to sign, I use something that's solid. When I have just the greater than sign, I'll use an open dot in the previous case. Well, we don't use open dots here, but what we'll do is we'll just write a dotted line. So same idea, but this time we'll just make it dotted to show that the points on the line actually are not part of our solution. Okay, so same first step, graph out the line, make sure it's dotted this time because there's no equality. And then step 2 is the same. Take your test point and find out which side to shade in. And in this case, since it's the same as the one to the left, that's what it's going to be. Okay. Hopefully this is pretty simple so far. Let's take a look at these ones. So once again, hey, it's the same line. I'm trying to make life easy for you. Same line, same line. Solid or dotted? Good, solid. So once again, I'm going to ask you to decide the region to shade in. So let's choose a test point. This time I will choose 0, 0 again and plug it into the equation. 0 this time is less than or equal to 3 times 0 plus 1. So 0 is less than 1. You bet. This is a true statement. So when it's true, you shade in the side that contains the test point. So therefore in this case, let's shade in the side to the right. And that's your answer. Similarly now for the last one. Same line. This time it's dotted. Okay, it's still less than, so we shade in the same side. Okay. And there you have it. You learn how to graph inequalities. Before we turn to the next page, be careful when you have the equal sign, the equality along with the inequality. Make sure the line is, that's correct, solid. Okay, just like before how we had a solid dot. All right, turn the page. Okay, here's your chance to try some of these. So here's another one. Notice this time the equation is not in that slope-intercept form. But if you like to do the slope-intercept form, by all means, change it to that form and then graph it out. Some of you might be thinking that's too much work, Mr. Lee. I'd rather just find the x-intercepts and y-intercepts. You can go ahead and do that too. Remember, when you do lines, you need 2 points. Once you got 2 points, connect the dots. I will do the y equals mx plus b form. So I will keep the negative 4y on the left side. I'll move the 2x from the left side to the right side, and then I get negative 2x plus 12. Then I'll have to divide everything by negative 4, so that'll be 1/2 x minus 3. And don't forget, because I'm dividing by a negative, please make sure you change the sign. So to graph this out, my first step once again is to graph out the line y equals to 1/2 x minus 3. Negative 3 is the y-intercept. 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right, 1 up. This is an equality as well as an inequality, so I will actually draw a solid line. And then the hardest part probably is to figure out a test point to figure out which side to shade in. I'll choose the test point of 0, 0. So choose test point of 0, 0. So 0 is less than or equal to 1/2 times 0 minus 3. That transforms into 0 is less than negative 3. That is definitely false. So which side do I shade in? The side not containing 0. That's just way down here. Done. Okay. You'll be given questions where you have to actually graph out inequalities as well. So we've done inequalities, but this will be a system of inequalities. So that's example number 3. So it's really the same thing, but let's just do each of them individually first. Let me label them number 1 and number 2. I'll use different colors so you can see the difference. Once again, it's your job to figure out how you want to graph this out. For number 1, I'm going to graph it out, okay, by using actually the x-intercepts and y-intercepts, just for fun, okay? So if I wanted to find the x-intercept, of course I let y equal to 0. So 4x equals to 8, x equals to 2. So in this case, I've got the x-intercept of 2, 0. Find the y-intercept. Once again, to find the y-intercept, you let x equal to 0. So negative y equals to 8, or you have the y-intercept of 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And in this case, I will then connect the line together, or connect the dots together. Solid because of the equality. And of course, I need to choose the test points. So I'll test my favorite point, the easiest of them all, 0, 0. 4 times 0 minus 0 greater than or equal to 8. 0 greater than or equal to 8? No way. So I'll shade in the side that does not contain a test point. That would be this side here. So you see how for this example I did not write into y equals mx plus b form? You don't always have to do that. Okay. But for equation number 2 I will, just for the sake of showing you that way again. So let's go 2y is greater than negative x minus 7. We'll divide both sides by 2. We get negative 1/2 x minus 7 over 2. And you got fractions, but nonetheless, they're not too bad. Negative 7 over 2 is the same thing as 3.5, so that's negative 3.5. Negative 1 over 2 means go down 1, right 2, down 1, right 2. Draw it like this. Oops, what did I do wrong? Yes, if you understood that, hey, the line should be dotted because there's no equality, give yourself a pat on the back. Congratulations. So let me just quickly draw in a dotted line. Okay, just a sketch right now. What's my last point I need to do? Yes, the test point. Which test point would you like me to try? How about 0, 0? 0 is less than 0 minus 7 over 2. 0 is, sorry, not less than, greater than negative 7 over 2. Totally true. So I better shade in that side that contains 0. That'll be over here. And now you're thinking, this looks really messy. What's my actual final answer? Well, your final answer is the region that has both types of shading, so what they call cross shading. And therefore, that would be this region here. So your final answer would be really you shading in this upper right region of the grid. Okay. Ta-da. Example number 4 is the same thing, except now you got a few more equations. But this time you're going to get actually enclosed regions. And from those enclosed regions, I'm going to ask you to also define the area. So I'll let you try these on your own. Okay, so if you want to stop the video, you can. Otherwise, I'll just continue to do this, and then we'll meet up after you're done. Okay. Label, because there's so many different things. Let's do the trickiest one first. That'll be the first equation. I will rewrite it as y equals or less than or equal to negative x plus 5. That, of course, is a line with slope -1 and y-intercept of 5. 1, 2, 3, 4, 5. -1. Solid line. Okay. Which side will I shade in? Let's quickly do a test point. 0, 0 plus 5. Oh yeah, 0 is less than or equal to 5. Oh yeah, totally true. Shade in the side that contains the test point. Then the next one, you got the line x equals to or greater or equal to 1. X equals to is always a horizontal line, so here's your horizontal line. Greater or equal to, I guess you can choose a test point if you wish, but of course greater than means it has to be bigger, so that would be this region over here. So notice now this is my shaded region so far. Okay. Last but not least, y equals to 0, so that's a horizontal line right at 0, and it's greater than, that means I want this region up here. So what do you think is the actual region that is enclosed by all three of these lines? If you saw this triangle here as the region, bravo. And now you just have to find the area of the triangle. So what's the area of a triangle? Base times height divided by 2. The base seems to be 4. The height seems to be 4. Divided by 2. I guess it's 8. 8 units squared. Okay. We'll do the same thing for the next one, part B. You figure out yourself if you wish. I'm just going to, let's call this number 1. I guess I'll solve for y. For y. Greater or equal to 3x plus 5. Y is greater or equal to 3/4 x plus 5 over 4. Kind of nasty. Well, we'll try. 5 over 4. 3 over 4. Looks something like this, I think. You've got the line x is greater than 1 again. That's this one. Doesn't look very good. I guess I'm doing this quicker, and I really haven't shaded things in yet, but you can do that along the way. I'm trusting you're doing this yourself before looking at my answer. Here's line y equals to 5. But because this is less than, here's your region. Once again, another triangle. Area in this case, 4 times 3 divided by 2. How about 6 units squared? Okay. One last bit, and we're done. Okay. So your homework's underneath here. Do as many as you want. For 1 to 8. The rest of those are ones you must do. And then come to class, ready to work. Life will be good. Alright, example number 5. Here we go with number 5. Write a system of inequalities. I've turned the tables on you. Now, instead of you being given the equations, now you're being given the graph. Go ahead and find the equations that match up the graph. Let's do easy first, shall we? First of all, let's label these. Let's go number 1, number 2, and maybe this slanted one, number 3. Okay, what's the equation number 1? Vertical line must be x. The shading here seems to be to the right of x, so that means it has to be greater or equal to. Once again, equal to because it's a solid line. That value of x seems to be 2, so there you go. Pretty straightforward. How about line number 2? Well, that's the horizontal line, so that must be y. It's on the x-axis, so it must be 0. And now the question you have for yourself is, what's the sign? Is it going to be greater than or equal to, or less than or equal to? Notice where the shading is. Is it above the x-axis or below the x-axis? So therefore, it must be below, less than or equal to. The hardest one is the slanted line. First of all, we have to find the equation of the slanted line. I gotta find 2 points to find the equation. How about this point right here, 2 comma negative 2? How about this one right here? That's 3, 4, 5, 6, 7, I guess. Yep, 7 comma 0. So how do we find the equation of the line? Y equals mx plus b. Don't forget we need the slope. So let's find the slope first. Those of you who had me last year, remember the slope song. I won't say it to you now, but 0 take away negative 2. 7 take away 2. 2/5. So y equals to 2/5 x plus b. How do you solve for b? Plug in a point. I'll plug in 7 comma 0. 2 times 7, that's 14 over 5 plus b. B must be negative 14 over 5. Therefore y equals to 2/5 x minus 14 over 5. But wait a minute, I want an inequality. Okay, so what's the inequality sign this time? So what's the sign going to be? Once again, here's where you need to choose a test point. Now in this case, the strategy is to choose a test point inside the region that you have so that you want a true statement. So I'm going to pick that point right there, 4 comma negative 1. So if I were to pick 4 comma negative 1, so choose test point, I can't spell choose, test point, this time I'm going to say inside the region. And of course then you're looking for something that's true, right? So the point in this case we chose was 4 comma negative 1. So negative 1, some sort of inequality sign, 2/5 times 4 minus 14 over 5. Oh, let's write out of space. That's 8 over 5 minus 14 over 5. 8 minus 14, what's that? Negative 6 over 5, negative 1. Which one's bigger? Well, that's negative 5 over 5. Seems to be that's bigger. So now you know the inequality sign must be bigger or equal to. And therefore the equation for the third one is y is greater or equal to 2/5 x minus 14 over 5. Done.